Well, we go on. So differentiation is the process of finding the derivative of a function. And this derivative, when we talk of the derivative, we are talking of the instantaneous rate of change in the dependent variable, given the change in the independent variable. So our functions will still be in form of y is equal to the function of x. At some point when we'll be introducing the product rule, the quotient rule, we'll introduce the u and v. But for now, y is a function of x. So by the end of the lesson, we need to know how to differentiate any given function. Then we are supposed also to be able to find the second derivative of any function. If you recall, when we were winding up the integration, we looked at the applications of integration in business cases. One of them was looking at the minimum and the maximum profit. And it is at that time that you are doing the second derivative of the given function. We'll be also looking at partial derivatives, gradient of any given curve, and then wind up with identifying the maximum and minimum turning point, which will be a repeat of what we did in the integration. So these are the rules of integration. We've done most of these things apparently. So we said integration, we normally add 1 to the power and divide by the new power. But when we come now to differentiation, it is the opposite. We multiply by the power, then we subtract 1 from the power. So we've been given a function of y is equals to x raised to power of n. We are going to drop the n and multiply by x. Then to the n, we subtract 1. This formula holds except when x is equals to 0. If you recall in the integration, our formula was holding except for a situation where x is equals to -1. Reason being, it will give us the 0, or it will eliminate the whole function. And in mathematics, we say 0 is nothing, right? So we go on, but it is something when it is raised as a power, because it converts that number into 1. For example, x raised to 0 is equal to 1. But if x is equals to 0, it's more or less null. Good example is this function. Y is equals to x5 raised to power 5. We are going to drop the 5 and then subtract 1 to the power. We are going to get 5 multiplied by 5 minus 1, which is 5x raised to 4. That is the first rule. The second rule is for constant. If you differentiate any constant, you're going to get a 0. Now I bring the meaning of x. This is because behind this constant, we have an x raised to power of 0. So I'll drop the 0 and multiply by the constant and get a 0. For example, if y is equals to 6, it's same as y is equals to 6, x raised to 0. So if I drop the 0 and multiply by 6, I'm going to get a 0. So the derivative of a constant is 0. Y is equals to 1000 is equals to 0. Y is equals to 632 is equals to 0. Any arbitrary constant. Then when we have a constant in front of a function, this is how we operate. Yeah, for example, we have a function of y is equals to cu, where u is a function of x. They're still going back. So you're going to take the constant outside, then you differentiate the function of u. You're going to have the constant c multiplied by now the derivative of u, du over dx. A good example is this one. Y is equals to 4x cubed. So you're going to take 4, then our 3 will be multiplied by 4, that is 12x, then 3 minus 1, which is 12x squared. If you have a question, interject. Then you have the sums or difference of function. When you have a sum or difference of a function, and our function is in form of u and v, where u is a function of x and our v is a function g of x, then our formula becomes, so it's like we are differentiating them separately. We first take the function of f of x, that is du over dx. We add now the function of v, which is the g function of x. It's easier said than done. Now, if, for example, we have this function, y is equals to 8x cubed plus 10x. These are two functions. So the first function is our u. So u is equals to 8x cubed, and our v is equals to 10x. So if we were to get now the dy dx, you are going to differentiate the whole function, and you are going to get 12x plus 10. So that's the addition rule. If we subtract, the same case, you are going to take them separately. So our dy dx, or rather if we take the du over dx, we are going to take 3 multiplied by 3 is 9, 9x squared. That is our u. Our v is 5x squared. So 5x squared is 5 multiplied by 2, x 2 minus 1, we get 10x. That is the rule for sum and for difference. So it is 2 in 1. That's why you have a plus and a minus. They go on. Then I have the product rule. And for the product rule, Grace Njoroge. Grace Njoroge is greeting us. Grace, can you hear me? Grace Njoroge. Grace, you can unmute. Don't know what is her issue. All the same, we'll go on. So you are in the product rule, and in the product rule, if y is a product of two functions, that is y is our uv, where u is the function of f, and v is the g function of x. Yeah. So then our formula becomes u dv over dx plus v du over dx. Can someone note the difference? What's the difference in this formula, the product rule? Kindly note, because this is the most common error that students do. U du over dx, then v dv over dx. No, we interchange them. It's a product rule. Are we together? Let's say, for example, we have this derivative, we have this function, y is equals to 2x squared, and in bracket 5x plus 3. We take our u to be 2x squared and our v to be 5x plus 3. So what happens? Let me plug in my laptop to power. Noted. Come in. You go on. So I've said what is keen to note it is u multiplied by dv over dx. I want us to go step by step. I'll take the first part. I can give them different color codes. Let me make this red. Unable to make them red, but hope you are able to see. I can increase the font. Well, I have this function, y is equals to 2x squared multiplied by 5x plus 3. The way they are, I split them. So my first function becomes my u. So my u is equals to 2x squared. Then my v is equals to 5x plus 3. To avoid confusion, differentiate what you've been given first in the formula. So I have my du dx is 4x. Then my dv dx is equals to 5. Are we there? Then we supply in the formula. So my u is 2x squared multiplied by dv over dx. My dv over dx is this differentiation. So it is 5. So it will be 2x squared multiplied by 5 plus my v is now 5x plus 3. 5x plus 3. Then I multiply by v. And my v is 5x plus 3. Then I multiply by du over dx. Du over dx is 4x. If you do that, we are at this point. So 2x squared multiplied by 5. Then my 5x plus 3 is supposed to be multiplied by 4x. Already we have a problem. It's supposed to be 4x. Kindly note that you're multiplying by 4x. Our du dx is 4x. It's not 5. Right? So if you open the bracket, then you are going to get now the answer. Now the challenge comes in. This is what I normally advise students when you are doing the subtraction. For instance, if we had a negative here, it's going to change this into negative. Negative multiplied by positive is, so kindly note, shall you get a negative? I think you are going to get such an example in the course of our class today. I want to give you this. Try that and give us the answer. It has already been differentiated for you. And look for a better question, an exam question. Product rule. Well, try that. We'll go first. Who has gotten the answer? Let u be x plus 5. Let your v be x squared plus 3. Have you gotten the answer? Eileen Langat. Mark Karaoke. Mark. Have you gotten the answer? Have you gotten the answer? And before I forget, we have our Cat 1 next week, which will cover the far that you've come. That's the good thing. So I'll go on in the interest of time. That was product rule. So our quotient rule is that rule for division. So if y is a quotient of two functions, and these functions are u and v, again, our u is the f of x, and our v is the g of x. Then our formula for getting the division or the quotient is v du over dx minus u dv over dx. Kindly note these are minus, then we divide by v squared. I have an example here. If my function is 2x squared plus 3 over x, I'll take my numerator to be the u, my denominator to be x. If I differentiate my u, I'm going to get 4x. And if I differentiate my denominator, I'm going to get 1. Then I apply it in the formula, the way it is. So my v is x. So x will be multiplied by du over dx, which is 1, minus u, which has given us, our u is 2x squared plus 3, then multiply by dv over dx, which has given us 1. If you do that, I've just applied that in the answer. That is what we are going to get as our answer. So you can see, we are opening the bracket, and this is where I was telling people to be keen. So I'm going to have 4x squared minus 2x squared. This will not be a plus, it will be a minus. Negative multiplied by positive, it's a negative. Well, we are multiplying by 1, so there is no change. If I open the bracket, I have negative 2x squared, and I had 4x squared. 4x squared minus 2x squared is 2x squared, minus 3 over my v is x, so v squared will be x squared. In most occasions, we don't change the denominator unless it is in a form that you can easily change, or that you can easily simplify. Let's say if that is the case, we have another one here. Du dx is 2x, and our dv over dx is equals to 2x because it is still x squared. So again, I supply in the formula. So it is u, which is, now we are starting with v. So it is v, which is x squared multiplied by, no, we are starting with the u dv over dx, u dv over dx minus v du over dx. Then we divide by v squared. So if we supply that in the formula, we're going to get our x squared multiplied by 2x, which is the derivative, minus our v, our u. Our u is x squared minus 3. Then dv over dx has given us 2x. Then from there you open the bracket. I've said in most occasions we don't change the denominator. Let's open the bracket. This will be 2x cubed minus x squared. Note these are negative. Negative multiplied by negative is positive. We are going to have a plus. Now we were supposed to open the bracket from behind because we have a 2x. So we multiply inside first. So this will be 2x squared body mass minus 6x. Then we open the bracket. If you open the bracket, we are going now to have minus 2x cubed minus multiplied by minus is plus. So we are going to have plus 6x. So that is what we have here. And then from there now, we quantify. Of course, 2x cubed will cancel out with 2x cubed plus minus. Then you are going to be left with 6x over x raised to 4. Cancel the x out. Our answer will be 6 divided by x cubed. If you want to simplify these things, you can say 6x raised to negative 3. 6x raised to negative 3. Then we have the chain rule, and chain rule is used to sort out the issues of functions. If we go to functions, we have a function of y is equals to un. We have now to expand our function of u to get the x. For example, and this is the formula. You can see we are coming from the order formula where we are just dropping our n down here. We multiply by the function, then in our n we minus 1. But it's a bit tricky when you come to the quotient. For example, you can see the function that we have here, the square root of x cubed minus 5x plus 3, which is same as x cubed minus 5x plus 3, all in the bracket raised to a half. When it is raised to a half, we say now it's the square root. So what will happen is our function of x cubed minus 5x plus 3 will be our u. Then our half will be our n. You can see. I want people to be observative. Because in this case now, when we cross multiply, you can see we are getting dy over dx, right? So it's like we are differentiating the function of x, but it is in u terms. So dy over du, then we multiply by du over dx. The result will be same as if we were to differentiate it in this form, only that we are taking it as a quotient of u, where u is the function of x. I'm taking some time so that people absorb. So if that is the case, then our u is x cubed minus 5x plus 3. So our function of y in u terms will be y is equals to u raised to raised to a half. So that when we differentiate, we multiply by a half, then we minus 1 to get negative 1.5. You can see when we are getting the derivative of a fraction, remember we are subtracting 1, so we'll always be left with a negative. If we were to simplify this is same as 1 over 2 square root of u, right? but you cannot take it back at this point. You wait until it's simplified. At the end, you can again return it to its original state because we are removing now the square root. So our du over dx, this function here, will be 3x squared minus 5. Then we apply our chain rule, dy over du, and our dy over du, we've gotten a half, u raised to negative a half. Then we multiply by 3x squared minus 5. So you multiply, this is what we are going to get. You can see we still have our negative a half. But when we'll be coming to the answer, we are going now to return to the square root. So everything that is affected by this half will go to the denominator. Kindly know that. If, for example, we had this function raised to negative 1 over 3, it's the cube root. Yeah, if it was raised to negative 1 over 8, it's the 8th root. Yeah. Any question? I have another example here of the, I want you to try this using the chain rule. Let your u be 3x squared plus 6x minus 5. So that your y is equal to u raised to 3 over 2. This one is an easy one because when you subtract, you are going to get a half. If the link expires, kindly log in the same link. I'm hoping you are differentiating using chain rule. This is a chain rule. dy over dx is equals to dy over du multiplied by du over dx.